chart. And this chart is part of your ART content specs. I didn't make it up. So today, let's just go over the chart. And your chart tells you what things are affected, and then we'll go over why. That comes up after. Okay, so the first one's receptor exposure. They used to call receptor exposure density. It's not called density anymore. It's called receptor exposure. All right, it's the same definition. It's the amount of radiation striking the image receptor, which should be on the chart. So let's just go down the list. Okay, so mass. Yes, mass affects receptor exposure. So the little X's are, yes, it does affect it. If there's no X, then it means it doesn't. Okay. So KBP, yes, that affects receptor exposure. OID is a matter of debate, but as far as they're concerned, it does not. Okay. SID does. Focal spot size does not affect it. Grids do. Tube filtration does. Beam restriction does. Motion does not. Anode heel effect, it does in a way, which I'll talk about in a little bit. Patient factors, meaning size of the patient, does. Angling the tuber part does not affect receptor exposure. Any questions? Okay. I think I put on your chart increase and decrease. Let's see what I put. I did. Okay. All right. So I put specifically how it affects it. So that it just means that if you increase the part where the mass is, it says if you increase mass, you get more receptor exposure. That's all that means. Okay. Contrast. This is the visible difference between any two selected areas of brightness. A little different than how we used to explain it. That's what contrast is. Okay, mass does not affect contrast. KBP does. OID does. SID does not. Focal spot size does not. Grids do. Tube filtration, it does. Beam restriction, it does. Motion does not. Anode heel effect does not. Patient factors will. And angling the tuber part does not affect contrast. Okay, spatial resolution, that's the sharpness of the structural edges recorded on the detail. Basically, it's just think of it, how fine a line can you see? Okay. When you get into digital, what is spatial resolution in digital? Line pairs per millimeter. Okay, in digital it's line pairs per millimeter, and actually contrast in digital is the bit depth of your system. Okay, so we're talking, this is in general. We're not talking about digital with this right now. Okay. All right, so spatial resolution. Mass does not affect it. KBP does not affect it. OID does. So does SID. So does the focal spot size. Grids do not. Tube filtration does not. Beam restriction does not. Motion definitely does. Okay. Anode heel effect does not. Patient size factors like that does. Angling the tuber part does. Okay. Distortion is just like a misrepresentation of the size or shape. Okay. Mass does not affect distortion. KBP does not. OID does. SID does. Focal spot does not. Grids do. Grids do not. Tube filtration does not. Beam restriction does not. Motion does not. Anode heel effect does not. Patient size does. And angling the tuber part does. All right, so reasons why. That's on your next page. Okay, so we'll start with receptor exposure. So as far as mass is concerned, the more mass you use, the more receptor exposure, right? Specific rules that I think you should know. Mass is directly related to receptor exposure. So if I double my mass, I double the receptor exposure. What percentage do you need to add to your image as far as mass is concerned, just to see a little bit of a difference? 30%. Okay, if you add 30% mass, you can just see a visible, I think they call it perceptive, just a little bit of a difference. 30%. Okay.
Visible.
A visible difference if you add 30% mass. To double it, it's 50. All right, KBP, definitely. Increasing KBP increases your receptor exposure. What if I want to double receptor exposure? What do I do to KBP? Good. If you want to double your receptor exposure, add 15% KBP. All right, SID definitely affects receptor exposure. We did the inverse square law in the summer. So increasing SID will decrease the receptor exposure. You're further away. Okay, grids.
Can you say that again? I'm sorry.
Increasing SID decreases receptor exposure. Think of the inverse square law. Okay, using a grid or increasing your grid ratio. You haven't adjusted anything. If you use a grid, what would happen to receptor exposure? If you use the same mass and then you stuck a grid in there, well, very good. It goes down because those grids absorb some radiation. Okay, so increasing grid ratio would decrease receptor exposure. Okay, filtration. If you increase filtration, it decreases receptor exposure. Remember we went over filtration in the summer. What does filtration do? It absorbs what? Good. It absorbs some low energy, long wavelength photons. So you're taking some things away. So you're decreasing receptor exposure. Okay, beam restriction. Whenever we say you increase beam restriction, what are we doing? Going this way or this way? Good. When you increase beam restriction, you're going this way. So increasing beam restriction decreases receptor exposure.
You said if you increase it, it decreases it?
It decreases receptor exposure. You don't get as much scatter, helping fog the film, I guess you can say. Okay, anode hue effect. This is really what they put this in there because they want you to know which end of the X-ray tube, anode versus cathode, has the strongest X-ray photons. Good. Okay, so receptor exposure is increased on the cathode side and decreased on the anode side due to the anode hue effect. Do you guys understand what the anode hue effect is? Okay. So, bless you.
Thank you.
Okay, so these electrons that get converted to X-ray photons coming off the cathode versus anode, they're a lot stronger because of that bevel, the anode hue. They go out a lot stronger over here and they're weak over here. So that's all that's saying. And we're going to talk about the different coming up, not just yet. We're going to talk about the effective versus the actual focal spot. Okay, does it say 3 things that make the hue effect more apparent? Okay, good. All right, so there's 3 things that make the hue effect more apparent. That just means you can see it better, supposedly. Okay, number 1, is a small anode angle. A small anode angle, like 12 degrees or less. Number 2 is a short SID. And number 3 is a large image receptor, which we mostly use now, like a 14 by 17. Yes. Okay, so here's my chalk. If you have a narrow angle, you're really going to be able to see it, supposedly. You're going to see the stronger ones here and the weaker ones here. Same thing with a large IR. With a small IR, you wouldn't be able to see it, supposedly, as much as a large image receptor. And the other one, I think it was number 2 that I told you, a short SID. It's more apparent. The hue effect would be more apparent. Okay. All right. Okay. Is line focus principle on there? All right. What is the line focus principle? We've had this since the very beginning. What does that mean? Line focus principle.
Like the direction of the ray, right?
No, it actually has to do with this stuff.
Oh, that's not what the beam with the ratio of the grid to the beam? Or how you angle the tube?
No, it has to do with the tube angle. It has to kind of do with the anode hue effect in a way. Line focus principle is just saying that because of this angle that they made on the bevel of the anode, all that's saying is you can have a large actual focal spot. So it's a large area of electron interaction, which is good because it dissipates heat because of that line focus principle. But because of the angle, we get a small effective focal spot, which is good for what? It's on your little chart. What is a small effective focal spot good for?
Small, like small things.
Good. Yeah, small things. So you want better spatial resolution. Okay, so a small effective focal spot is good for better spatial resolution. Okay, that's why they say if you're doing extremities, if you can, pick the small focal spot versus the large. Okay. All right, so the actual focal spot is the actual area where the electrons hit. The effective focal spot is the effect of that bevel. Always makes it smaller, which is what you want, okay, for better spatial resolution. The more spreading you get, the more blur. Okay. All right. We good with this? Okay. Moving on to contrast.
Magnification factor.
Oh, well, patient, what do you think? So if you had a big patient, would you have less receptor exposure or more? Less. Okay. So the larger the patient, the less receptor exposure. This is if you don't adjust anything. Okay, contrast. Contrast, according to the ART, they say it's the visible difference between any two adjacent areas of brightness. gonna get into digital with this test or with this comp, but once we get into digital, contrast, it's all a matter of window width. You just adjust it by window width and or the bit depth of your system. Okay. But this is exposure related. This chart is everything exposure related. Okay, so contrast, mainly I like to think of contrast when I think of how it's going to be affected. Think of, is this thing going to produce scatter or take away scatter? Scatter has everything to do as far as exposure is related to contrast. The more scatter you have, what happens to your contrast? Goes down, you get more grays. Okay. So as far as the gray scale is concerned, let's talk about grayscale. If it's a long scale, there's many shades of gray. That's considered low contrast. Okay, short scale is the opposite. Short scale, there's few shades of gray. That is high contrast. Okay, and then there's something called subject contrast, which is also known as differential absorption. What is that? Good. So that's with the contrast that's inherent within the patient. If you want to talk about differential absorption, it's just the different ways your body absorbs X-rays. You want to think of it like that. So let's talk about the chest area. Is that high subject contrast or low? High. Why? There's more air, so the air is black, and like your spine and your heart is white, black and white. Okay, so it's high subject contrast. What about the abdomen? Low. Because everything's about the same density. Okay, KBP. KBP is your controlling factor as far as exposure is related to contrast. The higher the KBP, the lower the contrast. Because of scatter, we're getting more grays. High KBP is low contrast. When was the last time you guys had this stuff? Don't remember. Your year's been pretty messed up. All right, OID. If you increase OID, you're creating an air gap, right? So what does scatter do? The scatter decreases because it dissipates in the air, okay? So if you increase OID, you're increasing your contrast. What does OID stand for? Good. So it's the object to the image receptor distance. All right. Grids. We all know grids. That's an easy one. Increasing your grid ratio does what to contrast? Increases. Good. You're getting rid of some of those grays.
I missed that.
Increasing your grid ratio increases contrast. You get higher contrast. Okay, tube filtration's the funky one. So if you increase tube filtration, what you guys tell me that tube filtration does? Absorbs which ones?
The low energy.
Okay, so it absorbs the low energy X-ray photons. What interaction is with the long wavelength, lower energy photons? What interaction in your body? What interaction, photon interaction in your body is with long wavelength, low energy photons? Good. Photoelectric absorption, right? So we're getting rid of those. So what are we going to have more of? What interactions? Competence, okay? So with tube filtration, you increase the tube filtration, you're going to have more Compton. What is Compton? Scatter. So what happens when you have more scatter to contrast? Goes down. Okay, so increasing tube filtration will decrease your contrast. Okay, beam restriction. Increasing beam restriction, are you doing away with scatter or are you going to increase it? You're going to decrease the amount of scatter. Okay, so increasing tube filtration will increase your contrast.
Tube filtration or beam restriction?
Beam restriction. Did I say tube filtration?
Yeah.
I started with, okay. So, sorry, go back. Increasing beam restriction will increase your contrast. Okay, patient factors. The bigger the patient, what happens to scatter? Get more or less? Get more. Okay, so increasing the patient size will decrease your contrast.
So pretty much when there's like gray, then it decreases the contrast. When there's less gray, then it increases the contrast.
Correct. Does everybody understand that? And scatter is all about making more grays. We good? All right. Spatial resolution. That's just the degree of sharpness that you see. I put umbra and penumbra. Is sharpness umbra and unsharpness penumbra on there? Don't put it down then. Those are really old terms and I'm hoping, as far as I know, they did away with them. Okay, so there's three main geometric factors. This is as far as exposure is related to spatial resolution. OID is one. Increasing OID decreases spatial resolution. Decreases. Why would increasing OID decrease spatial resolution?
Because it magnifies.
Very good. Okay, because increasing OID increases the magnification, which makes things blurry. This is going to drive me nuts this semester.
Are they actually taking out that room?
The conference room is done. But they haven't put together the table or anything in that, or the view boxes in the lab. They just, I don't want to talk about it anyway. I run after the electrician, you're like, hey. Oh well, okay. So the three main geometric factors we said, increasing OID decreases spatial resolution. Increasing SID would do what to spatial resolution?
It would increase it.
Good. Increasing SID increases spatial resolution. There's less magnification. Okay, focal spot size is the last one that is considered a geometric factor. Increasing the focal spot size decreases spatial resolution. You get more spreading of the image.
So increasing, decrease.
Increasing focal spot size decreases spatial resolution. The smaller the focal spot, the better the spatial resolution. Okay, motion, that makes sense. Increasing motion, what happens to spatial resolution? Decreases. See it blurry. Increasing the patient size. So they're further away from the image receptor because they're big, so you get more magnification. So increasing patient size decreases spatial resolution. angling the tube apart. What happens when you angle the tube apart? Decreases. It gets elongated or foreshortened, right? So increasing the angle decreases spatial resolution. Decreases spatial resolution. You guys, if you have a question on your test, your ART, and they give you different projections, like the Towns projection when you use 30 degrees caudad angulation, or Towns when you do the 37, which one gives you better spatial resolution? The least amount of angle will give you the best spatial resolution. The least amount of angle will give you the best spatial resolution. The more you angle the beam, the less spatial resolution. Right, distortion. It's just the misrepresentation of the size or shape of the object. So there's two types of distortion. The first type is shape or true distortion. This is either by angling the tube or the part. If you angle the tube, you get elongation. So here's my forearm or an elbow. If I angle the part, you get foreshortening. Okay, so angling the tube is elongation. Elongation, angling the part is foreshortening it. Okay, the second type of distortion is size or magnification distortion. Two things that affect that. We already went over it. What two things would affect magnification? It would affect spatial resolution as well, but what factors? What things that you can do? OID is one. Okay, so increase in OID, what happens to distortion? Increases it because it makes it magnified. Okay, increasing OID increases distortion.
Question, you said part is foreshortening? Angling the part?
Correct. Okay, what's the other size distortion factor besides OID? SID, okay. Increasing SID would do what to distortion?
Decrease it.
Decrease it. There's less magnification. Magnification factor formula. Yes, sir.
Sorry, what was OID again? Increase OID is...
The other one, SID?
Increase OID is increase
Distortion. Sorry. Okay. Magnification factor formula. SID over SOD. What's SOD? Good. How would you get this if they didn't say the source to object distance is blah? How do you find source to object distance? OID is one. I can't see who talks. Yeah. So this is what? SOD. SOD. All right, so you might have a question like this on your ART exam, I don't know. But a typical thing that I see in registry review, they don't give you specific numbers. Not saying that you might not get specific numbers and you have to plug it in to this magnification factor formula. What I see on a lot of registry review stuff is if you put the part halfway between the tube, kind of like what I drew here, and the IR, how much magnification are you going to get? If you put the part halfway between the tube and the image receptor, how much magnification are you going to get?
250%.
What'd you say back there?
That's times 2.
Times 2. How'd you get that?
I guess.
Oh my God. Well, let's just put in numbers, okay? So typical SID is 40 inches, right? So SID over SOD, so halfway between would be 20, right? 4 divided by 2. So it's a factor of 2. Pretty good. Okay. So it's double. It'll be double the size, or 100% magnification. Don't forget this. I see it on a lot of stuff. I hear it too. All right. Where are we? Okay. So are we still on distortion?
Yes.
Okay. So OID. Increasing OID does what to distortion? Increasing SID does what to distortion? Decreases. Good. Increasing the patient size would do what to distortion? Increase it. More magnification. Increasing the angle of the tube or the part, the IR, does what to distortion? Increases it. Okay. Almost done. I told you this is an easy one. Is it easy so far? Okay, good. I like to hear that. Okay, technique charts. This is just briefly going over technique charts. There's something called the APR or APT, automatically programmed techniques. These are like our system, our new system. All you do is press the body part and it does everything. Okay, so that's, anatomically programmed techniques, or APRs. All right, calipers, they just want you to know that the caliper, if you want to use it, you can measure the body part with the caliper. Okay, fixed versus variable KBP charts. This is still on the registry stuff, unfortunately. So there used to be such a thing, and I'm sure there still is out there. So if it's a fixed KBP chart, so just like it says, the KBP stays the same, okay, and we're going to adjust the mass. So for every 4 to 5 centimeters in body thickness, you multiply the mass by 2, by a factor of 2. Okay, variable KBP charts. You set a mass and you adjust the KBP, their variable KBP. For these, for every 1 centimeter, you increase the KBP by 2 KBP.
For every 1 centimeter?
For every 1 centimeter, you would increase KBP by 2, plus 2. Okay, special considerations, casts. If it's a wet cast, they recommend increasing KBP by what? Oh, you guys didn't have Ronnie. Ronnie would shoot you.
Somebody mentioned it to us, but I can't remember.
15. Wet cast should be increased, KBP should be increased by 15. You guys don't know because you just hit a button.
What do you mean by 15? Like this at 15?
KBP. If it's a dry, these are plaster casts, by the way. If it's a dry plaster, it's increased KVP by 10. Add 10 KVP.
Right?
Yes, if it's dry. The fiberglass one, some places say you don't really need to adjust it at all, and some places will say that you need to add 5 KVP. Add 5 KVP for the fiberglass ones.
So add 5 to the. Just
Whatever
5
KVP,
total?
whatever,
Yes.
correct.
Oh, it's like if you have a hand and normally you have 50 kbp, you'll do 55.
Correct.
If it's 5.
If it's fiberglass. Some places say don't add anything to fiberglass because sometimes the fiberglass is only like here and here. So it's like here, there's nothing there. So it depends. Okay, pathologic factors. This is throughout your registry stuff too. There's such a thing called additive factors versus destructive. So something like an additive process, that would be like ascites. They're full of fluid. Or someone with a big, huge tumor.
How do you spell that?
Additive,
No, ascites.
A-S-C-I-T-I-S. You're asking me to spell. All right, so additive processes, you would add 5 kVp onto what you normally do. And subtractive or destructive processes like emphysema, that would be one. You would subtract 5 kVp. Okay, on your outline it has stuff about age specific, and we did this in the summer. Obviously, you guys know if you had a PD, how would you do your technique? I mean, as far as KVP and mass.
5 kbp, low mass.
High KVP and low mass. Okay, that's all that is. Contrast media. Water soluble iodinated contrast, what's the recommended KVP? This was way back when COVID hit us. What's the recommended KVP for barium?
100.
Okay. Recommended KVP for water soluble iodinated is 70 to 75. And recommended KVP for barium is 100 to 120 KVP. Okay, last thing, AECs, automatic exposure controls. These are the units that there's some kind of chamber. There's 2 different kinds, and I think I go over it in the spring or something like that. Well, there's 2 different kinds of chambers that are underneath the table, and when x-rays go through the patient and hit the chamber, they terminate the exposure. Okay, that's what an AEC is, automatic exposure control. So basically, what thing don't you have to use on the control panel if you don't want to? Mass or KVP?
No.
Mass. Because when a certain amount of x-rays hits that chamber, or that ionization chamber, or whatever it is, it shuts the exposure off. Okay. All right, so as far as AECs are concerned, what do I want you to know? The only thing I want you to know right now, because in the spring I'm going to go over how they function. Okay, so the chambers are always situated below the patient, somehow or another. Some of them are below the IR, but I'll go over that later. Okay, so if you selected like the center chamber, and most of them have 3, okay, 2 on the outside, 1 in the middle. Some of them have 5, like our Bucky in there. But anyway, so if I selected the center chamber and the body part was over here, would the exposure be too light or too dark? Too light, because those x-rays are going to hit that center chamber and it's going to cut the machine off. Okay, so if you don't have the body part aligned to the chamber that you selected, it's going to be too light. What if I did a PA chest and I had the lateral button selected? which is the center chamber. Would it be too dark or too light?
Too dark.
Good, it would be too dark. Why would it be that dark?
Because of the overhigh contrast.
Because what?
It would over-penetrate.
It would over-penetrate because it's trying to get through the spine. Normally you have the two outer chambers for a PHS. So when the x-rays hit those outer chambers, it cuts it off. There's not much there. Okay. But if you have the center chamber, it's trying to get through the spine, so it would be really dark. Okay. All right, the last thing, exposure adjustment. Sometimes there's a button, plus or minus density. It just, different books say different things, but usually the plus or minus is 25%. And they still call it density control. Ah, should be receptor exposure. All right, pretty easy. Yeah.
Here we go with this.
See, so you'll be ready when we do these. Get it over with. Any questions, you guys? Email me if you do, if you look it over and you think, what the heck was she talking about? Yes.
Just missed